Hi, in this video we see how we combine the chain rule and the basic differentiation rules to obtain the chain rule version of these rules. We already saw rules for differentiating sum, difference, product, and quotient of functions. The chain rule, on the other hand, is used to differentiate a composition of functions. Take, for instance, a function c of x, which is the composition of function f with function g. So that is, c of x is f of g of x. Then the derivative of c of x is the derivative of f evaluated at g of x times the derivative of g of x. It is difficult at first to use this formula in order to differentiate a composition of functions, since it seems that we will need each time to find functions f and g to decompose c. In this video, I will use a slightly different format for the formula, which makes the application of the formula straightforward. Another possible way to rewrite the chain rule is to label the function g of x by u, so that u is g of x and g prime of x becomes the derivative of u, which is du dx. So you can use u prime also if you prefer. Therefore, c of x, which is f of g of x, can be simply rewritten as f of u, and the derivative of c of x with respect to x becomes the derivative of f of u with respect to x. That's the right-hand side of the chain rule. We need to keep in mind that u simply replaces any function of x. So f of u is a function of x itself, and it does make sense to compute its derivative with respect to the variable x. Now f prime of g of x times g prime of x simply becomes f prime of u times du dx, and that's the left-hand side of the chain rule. Overall, the chain rule says that the derivative of f of u with respect to x is f prime of u times du dx. And this might seem hard to understand at first, but applying this version is quite simple. This new version of the chain rule allows us to take any of the basic differentiation formulas that we have seen and rewrite it in its chain rule version. For instance, take the function x cubed. Which basic differentiation formula would we use here to obtain its derivative? The power rule, of course. Its derivative is 3x squared. So on one side of the equation we have the derivative of a basic function, and we could say that x cubed is f of x, and on the other side its derivative, 3x squared, which would then be f prime of x. Now the chain rule is the rule we use when we want to differentiate the composition of f with a function of x. Call that function u. Then we use the chain rule to differentiate f of u, and the rule again says that the derivative with respect to x of f of u is f prime of u times du dx. In our example, f of x is x cubed, so f of u is u cubed. F prime of x is 3x squared, so f prime of u is 3u squared. And overall, the chain rule gives in this case that the derivative with respect to x of u cubed, keep in mind that u is a function of x, is 3u squared times du dx. For example, let's say that we want to compute the derivative of x squared minus 3 cubed. This is exactly like differentiating u cubed with respect to the variable x, where u is the function x squared minus 3. According to the chain rule, the derivative is 3u squared times du dx. Replacing u by x squared minus 3, the first term gives 3x squared minus 3, all of that squared. And then du dx is the derivative of x squared minus 3, so the second term gives 2x minus 0. We can regroup the factors 3 and 2 together to get a factor of 6, and the derivative obtained is 6 times x squared minus 3 squared times x. Let's verify the answer just obtained by computing the derivative without the use of the chain rule to see that we do get the same derivative in the end. In order to differentiate x squared minus 3 cubed without using the chain rule, we are going to expand the expression to get a polynomial that is not factored. On the right-hand side of the equation, we have expanded the polynomial and have obtained x to the power 6 minus 9x to the power 4 plus 27x squared minus 27. Now we can obtain the derivative by using the power, the sum, and the difference rules. We get that the derivative is 6x to the power of 5 minus 36x cubed plus 54x minus 0. To see that this is the same as the derivative obtained on the previous slide, we will factor our answer. All three terms share a common factor of 6x, and therefore the answer can be rewritten as 6x times x to the 4 minus 6x squared plus 9. Finally, the expression within the bracket is a perfect square, and our answer is equal to 6x times x squared minus 3 squared. This is the same expression as the one obtained for the derivative on the previous slide. So I hope that you're convinced that no matter what we do, we will obtain in the end the same derivative. It's just that using the chain rule makes it a lot easier because we don't have to worry about expanding our expression first, as we just did in this slide. In our second example, we want to find the derivative of sine of x cubed minus 2. This is a function of the form sine of u, where u is the function of x cubed minus 2. We need to use the chain rule version of the basic differentiation rule for sine. You will recall that the derivative of sine is cosine. So instead of having the derivative of sine of x equal to cosine of x, the chain rule version of that rule is obtained by replacing x by u. So the derivative of sine of u with respect to x is cosine of u, and we multiply by du dx. Again, observe that to obtain the chain rule version, we merely replaced x by u and multiplied by du dx. All chain rule versions of basic differentiation rules are obtained this way, and on the next slide we will see many other examples. But now let's continue working out the derivative in this problem. Here u is x cubed minus 2, so cos of u is cos of x cubed minus 2, and du dx is 3x squared minus 0. Finally, I rewrote my derivative as 3x squared times cos of x cubed minus 2. I prefer to put any factor in front of the cosine function to avoid any possible confusion. Otherwise, one may think that the answer is the cosine of the product of x cubed minus 2 with 3x squared, which is not the case at all. On this slide, you have a list of basic differentiation rules on the left column. For instance, the last line has the celebrated rule, the derivative with respect to x of e to the x is e to the x itself. On the right column, you have the chain rule version of these rules. Note once again that all we have to do is replace x by u in the basic differentiation rule and multiply by du dx. For the last rule, this gives the derivative with respect to x of e to the u is equal to e to the u times du dx. Note that the third rule on the left is the power rule. On the right, you find its chain rule version, also called the generalized power rule. It says that the derivative with respect to x of u to the n is n times u to the n minus 1 times du dx. It is that rule that we have used in our first example to differentiate x squared minus 3 cubed, because it is of the form u to the n with this time n equals to 3. Now stay tuned for the next video where we see how to combine the chain rule with other differentiation rules such as the product and the quotient rule.